Page 5 of quadratics. This is a really important page. Do you see and remember that the standard form of the quadratic equation is ax squared plus bx plus c equals 0? Well, the equals 0 is only sometimes, okay? When does the quadratic equation equal to 0? Well, the quadratic equation is equal to 0 whenever the quadratic or the parabola that it forms is at the height of 0, which are these 2 points here, okay? Remember when you have a quadratic and it crosses the x-axis at 1 or 2 points, then it has x-intercepts, okay? And these x-intercepts can be found by using the quadratic formula or using factoring or using your calculator, okay? There's different ways of finding it. And the last page, you've spent some time actually finding the x-intercepts of the quadratic equation. And you probably discovered that, you know, sometimes the math wasn't too nice, okay? So I'm going to show you, you know, what contributes to the math being nice or not, okay? So do you see how here I have shown that inside the square root sign there's a little complicated expression there, b squared minus 4ac, okay? So there's a contribution by every single coefficient of the quadratic equation. The b, the a, and the c, they all contribute to making a number that is inside the square root. And depending on what number that is, you're going to have a nice answer or you're going to have an awful answer in terms of complexity. I have like 4 possible answers here, okay? And usually this type of answer is the one you're going to see in the book problems. When you get, they want you to have a nice round number so that you don't have to use your calculator, so you don't have to use the square root sign. So when you do a basic problem, usually you're going to get a nice number like square root of 4 in here. So you're going to do b squared minus 4ac, which is quite a complicated process. And at the very end, you're going to get a nice number like 4, which is a square. And then you're going to take the square root and you're going to get a 2. And you're going to go, wow, that was really nice. Well, normally that doesn't happen very often. Only in special cases that happens. But in the book, it happens all the time, right? Okay. Now, when the book gives you a calculator problem or a problem where they want you to do the square root, then the b squared minus 4ac is going to come out to be a number that is not a perfect square like 3. Okay, so that's going to end up being 1.732 goes on forever. And it's going to make a messy decimal answer, or you're going to have to use square root signs just like we did on the last page. And then sometimes the book is going to give you a problem where b squared minus 4ac is going to work out to be 0. So b squared is actually going to be the exact same value as 4ac, and when you subtract them, you get a 0. And that's a really special case, and we're going to talk about what that looks like when you graph it. Then last of all, there's a case which we don't see too much in this course, which is that the b squared minus 4ac turns out to be a negative number. So the 4ac part of it ends up being so big that it's bigger than the b squared part of it. And you can see that happens a lot of times, okay? In real life, like 50% of the time, okay? But in the book, not too often, okay? Okay, so what happens when the inside part of the square root sign becomes each of those things? Well, you might think, well, it's just the difference between having a messy problem and a nice problem. But actually, you can kind of see the difference between those cases by looking at a graph of the quadratic equation, okay? So I'm going to use different colors to signify each one. So I'm going to make the green case, which is this nice case here. And then this quadratic is going to look like this, which is what we typically see. It crosses the x-intercepts at 2 points, okay? Now I'm going to draw one that we don't usually see in this book, which is the square root of negative 4 case, okay? Which you're like, how can you take the square root of negative 4? Okay, maybe if you remember in past math class, you might have had imaginary or complex numbers. Imaginary or complex numbers are the solutions to negative square roots of negative numbers. So what does a square root of negative 4 inside the square root sign for the quadratic formula look like when you graph it? It looks like this, okay? A parabola that does not touch or cross the x-axis. So there are no x-intercepts. So there are no real solutions to square root of negative 4 also. So basically there's no solutions to the quadratic formula in this case, right? And so there are no x-intercepts, and because there are no x-intercepts, the parabola does not cross the x-axis, okay? And you might need to think about that a little bit, about how that all falls together, okay? That's a really important concept that often just knowing and understanding that is enough to get you a couple points on the quadratic equation problem on the exam. Finally, there's nothing really, and then finally there's the square root of 0 case, okay? The square root of 0 case sure is easy math, right? But what does that mean? When the part inside the square root sign is 0, what happens? Well, like let's look back at the last page. Sometimes we got something like 2 plus square root of 3, right? But what if you get 2 plus square root of 0? Then what? That's just, or I'm sorry, 2 plus or minus, right? 2 plus or minus the square root of 0. 2 plus or minus the square root of 0, well, if you add 0, you get 2. If you subtract 0, you get 2. Both solutions are 2? What does that mean? Well, actually what it means is that you are going to have one x-intercept. How can you have one x-intercept? You got the parabola. It's got like two sides to it. Isn't it always going to cross the x-axis at 2 points? Well, there's that very special case where you lower the parabola until it touches the x-axis only at the vertex. Okay, and that is the case that the inside the square root sign is square root of 0. Okay, and then finally there's this case which I brought up, but it's not really different. When you have a square root of 3 or some messy number here, the only difference between this case and the square root of 4 case is the square root of 4 case, you might be crossing the x-axis at a nice round number or a nice round fraction, and when you have a square root of 3 here, it's going to cross at a terribly messy decimal. Okay, so this case of square root of 3 is not really a different case. So there's only really 3 cases. There's the case where you have a positive number inside the square root sign. The parabola is going to cross at 2 different places. You're going to have the case of 0 inside the square root sign, and then it's going to be this case where the parabola exactly touches the x-axis. And then finally, you're going to have the negative number inside the square root sign, which means that you are not going to touch at all, which is this parabola right here. It doesn't touch the x-axis. That'll give you a negative sign in the square root. So actually, just knowing the b squared minus 4ac quantity gives you a lot of information about the parabola. You don't need to do the entire quadratic equation to know some valuable information about the parabola. You only need to do b squared minus 4ac, and you only need to do it far enough so that you know if that quantity is 0, greater than 0, or less than 0. Isn't that neat? Okay, so this table here only is summarizing what I just said. And it uses a different name for b squared minus 4ac because that's kind of a mouthful to say. It uses the delta sign, which they call the discriminant. Okay, so when they say discriminant, when they say delta, they're talking about b squared minus 4ac, but actually that is just talking about the number that is inside the square root sign after you do the calculation b squared minus 4ac. Okay, when they say roots, they're talking about the x values that make the quadratic equation 0. Okay. And it's kind of funny that they do say, look, 2 distinct linear factors, 2 real distinct roots, and that is when the quantity inside the square root sign is greater than 0, right? And then they say 2 identical linear factors, and you're like, what do you mean 2 identical linear factors? Like if you have 2 plus or minus 0, that's only one factor. It's 2, right? But remember that whenever you factor a quadratic equation, you end up with 2 binomials here, and even if they're the same, you can see that you have the same factor twice, right? So that's why they say 2 identical factors, okay? Unable to factorize means there's no real roots, or there's a square root of -4 or something here. That'll mean that the discriminant is less than 0, okay? So that means it does not cross the x-axis. Okay, so let's go down and do some of these. All we're going to do is check out the discriminant, so we're not going to do all that calculation we did before. All we're going to do is do a b squared minus 4ac. We still need to discover that here the a is 1, the b is 7, and the c is -3. But now we're just going to plug those in. 7 squared minus 4 times 1 times 3, or -3 actually, right? -3. And then we're going to multiply that out and do the subtraction. So 49 minus or plus 12, right? -4 times -3 is plus 12. And it says, by using the discriminant only, state the nature of the solutions. So we would say, oh, well, here the discriminant is positive. I think it's more mathematically correct if we do delta is greater than 0. And then we just say that the nature of the solutions are two distinct real roots. Okay, now we'll go to E. So x squared plus bx plus c. So our a is 1, our b is 1, and the c value is 5. So we're going to have b squared minus 4 times a times c, and that gives us 1 minus 20, and that's going to be a negative number, right? So delta is less than 0, which means there are no real roots. Okay. Then c. Now we have a is 3, b is 2, c is negative 1. So b squared minus 4ac is going to be 2 squared minus 4 times a times negative 1, which is c. And this looks like it's going to be, let's see, it's going to be a positive number, right? So delta is greater than 0, which means that two distinct real roots. Okay? Alright. Now it says, by using the discriminant only, determine which of the following quadratic equations have rational roots, which can be found by factorization. So that would mean that the b squared minus 4ac is going to come out to be a nice perfect square. Okay? That doesn't happen too often except in the book. So here's a, here's b, here's c. Okay? So it's going to be b squared, which is negative 5 squared, minus 4 times 6 times, which is a, right, and negative 6, which is c. And then if we work that out, it's going to be 25 minus, or plus, right, because it's negative times negative. 4 times 6 times 6, that's equal to 24 times 6, which is equal to 144. And when you add those together, it's kind of nice. You get 169, which turns out to be a perfect square. If you put that in your calculator, you'll find that's a perfect square of 13. So, yes, rational roots. Okay? What about this one? A is 4, b is negative 3, c is 2. b squared, negative 3 squared is 9, minus 4 times a times c, and that'll give us 9 minus 32. And that is a less than 0, right? So that's not going to be not rational roots. In fact, they're imaginary roots. Last one, a, b, c. So here we're going to have b squared minus 4 times a times c. It's going to be 16 minus 12, which is equal to 4. Square root of 4 is 2, right? So yes, there are rational roots here. Okay, for each of the following quadratic equations, determine the discriminant delta in simplest form and draw its sign diagram. Hence, find the values of m for which the equation has repeated root, two distinct real roots, and no real roots. Okay, so remember, repeated root means that delta is equal to 0. Two distinct real roots, delta is greater than 0, and no real roots is delta is less than 0. Okay, and sign diagram is just a number line with signs above it. Maybe you've never done it before, but not too hard. I'll do a few examples and you'll catch on. So in this case, it's pretty weird because our c value is a variable. How are we supposed to do that? How are we supposed to find the solution if we don't know all the values a, b, and c? Well, actually, we're just going to use the quadratic formula, and then we're going to use the m instead of the c, and then we're just going to carry it forward using algebra. Okay? So this, for example, we're going to have a equals 1, b is 4, and c is just going to be m. So we're going to find the delta value here, and it's going to be 16, which is b squared, minus 4 times 1 times m, which is going to be 4m, right? And we want to know when is it a repeated root, which is delta equals 0, and when is it going to be delta greater than 0, when is it going to be delta less than 0. So what we're going to do is we're going to make a number line, and we're going to put on all the possible values of m, and at some values of m it's going to be 0, and at other values of m it's going to be positive or negative. The first thing you do is you figure out when is the delta value going to be 0. And let's see. So the number line is the m, and then the sign we put around this thing is going to be to mark the zeros. And you still don't know what I'm talking about, but I'm going to show you. Okay, first you're going to solve this equation here. 16 minus 4m equals 0. When does the discriminant equal to 0? What m makes it equal to 0? So we're going to have this, and then we're going to do 16 equals 4m, because we're going to add 4m to both sides, and then that'll get 16 equals 4m. Now we know that m has to equal 4, right? So we're going to put 4 here on the number line, because that is a very important value here. And then we're going to mark the 4 with an O. The O here means 0. So at the value of m equals 4, the delta is equal to 0. That's important, okay? There are no other points where m can make the delta equal to 0. That's the only solution to this equation here, 16 minus 4m equals 0. Okay, that's important. Since there's no other place where m makes the delta equal to 0, all the other values are going to be either positive or negative. Okay, and since if you graph this, it's going to be a nice curvy function. There's not going to be any discontinuities, and we're going to know that, like, for example, on the left side of 4, it's going to be all plus or all minus, and on the right side of the 4, it's going to be all plus or all minus, and it's not going to be like plus and minus on the left side of, or on the right side of 4, and vice versa. It has to be all minus on one side, all plus on one side, because it only crosses the x-axis at one point. Okay? All right. So we marked this number line with the 0 here. Now we're going to test another value. So let's test a value like 10. If we put m equals 10 into the equation here, we're going to get a number, a delta that is less than 0. So I'm going to mark this negative, right? And then I'm going to test a value here that's less than 4, which is like 0. And when I put 0 in for m, I'm going to get 16 minus 0, which is a positive number. Why don't I have to check every other single number? Because I know that the function delta here is never going to be 0 at more than one point. And like, let's say, I'm going to graph it here really quick, okay? So at the point 4, at m equals 4, the delta is 0. I know that at m less than 4, that the function is positive. I know that m is greater than 4, the function is negative. And if I don't have any other 0 points, you can see that it's impossible for this function to go from being negative to positive. And vice versa. On the left side, you can see that the function is never going to go from being positive to negative. Okay? So now I know that all the points to the right of 4 are going to yield negative values. All the points to the left of 4 are going to yield positive values. So I don't even need to test any other points. I only tested 2 points, and now I know the whole history of the thing. Okay? All right. So now I'm going to say that here at 4, it's going to be case 1, right? And I'm going to write that here. At 4, it's case 1. And then, which is a repeated root. And then 2 distinct real roots happens when the delta is positive here. Okay? And then last of all, no real roots happens when delta is negative, which is here. Okay? So those are the three possibilities. Okay? So if I wanted to write this, the full solution, I would write something like if delta is, or if m is less than 4, then delta is greater than 0, which means case 2, right? And if m is equal to 4, then delta is equal to 0, and it would be case 1. And finally, if m is greater than 4, then delta is less than 0, and that would be case 3. Okay, then maybe I would write it out all like that if I wanted to. I just wrote it very compactly in this number line. Okay, and if you just do that, that's fine too. Okay, last one. So now I have a equals m, b equals negative 3, c equals 1, right? So in this case, I'm going to put b squared, which is going to be 9, negative 3 squared, minus 4 times m times 1, which I don't need to write there. And then I can see, okay, when does that equal to 0? 9 minus 4m. So 9 minus 4m, when is that equal to 0? Well, 9 equals 4m, m equals 4 divided by 9. So that is when the value, well, that's the value of m that gives you the 0 value for delta. And then what about to the right of 4/9? So I would put a number like 10 in, and then I would get 9 minus 40, which is going to be a negative number, so I can put negative here. And then I'm going to put a number like 0, and then I'll get a positive number. So delta is positive to the left, delta is negative to the right, and delta is 0 here at 4/9. So if I was going to write the solution all out, I would say when m is equal to 4/9, then delta is equal to 0. When m is equal to or is greater than 4/9, then delta is negative. And when m is less than 4/9, then delta is positive. Okay, and then remember that when delta is positive, that means it has two distinct real roots. When delta is equal to 0, it has two repeated roots, etc. This last section I'm going to divide into two parts. Okay, the first part is for people who have a lot of difficulty with algebra and factoring, and you cannot go to the end of this without intense suffering. The last part would be for those people who are okay at algebra and factoring, and you can go ahead and go all the way to the end. Okay? Alright, so number 4. Number 4 is like an advanced version of what we just did. Okay? First of all, you don't have to do this part. It says that you're going to classify each one of these values of k, so that the k, when does the k give you two distinct real roots, when does it give you two real roots, when does it give you a repeated root, when does it give you no real roots. Two real roots is the same thing, or is like a repeated category, because two distinct real roots, you have two real roots. A repeated root, you also have two real roots, so just ignore this one. So basically just look at these three categories, which is just like the one above, right? Okay, so like for a, we have this function here, where a is going to be 2, b is going to be k, and c is going to be negative k, right? And we're going to do exactly what we did before. Okay, so a, we're going to have b squared minus 4ac, and we want to know when that's equal to 0. So we're going to put k squared minus 4 times 2 times negative k equal to 0. Okay, and then this is the part where if you're bad at algebra, stop here, okay? And then just move on to the next one. So let's look at the C one. C, we're going to do the same thing. C is going to give us, let's see, the A value for C is 1, right? The B value for C is k plus 2, and the C value for C is 4. So I'm going to put b squared minus 4ac. It's going to be k plus 2 squared minus 4 times a, which is 1, times c, which is 4. And then we want to see where that equals to 0, just like last time. Okay, and again, if you're bad at algebra, you're going to stop here. Finally, e. Okay, e. So here, the a value is 1, the b value is 3k minus 1, and the c value is 2k plus 10. Okay, and then you're going to be here, you're going to be 3k minus 1 squared minus 4 times c, which is 2k plus 10. 2k plus 10. 2k plus 10. Barely fits. Okay, and now what you want to know when that equals 0. Okay, now's the part where if you're pretty good or fast at algebra, now you can continue watching, and I hopefully won't lose you. Okay, so A. So in this case, we want to know when this is going to be equal to 0. So we're going to simplify k squared plus 8k equals 0. So this is a little bit more complicated than before, right? Because before we just had a linear equation we solved for the m value, and we got, one number. Here it's a quadratic, so it's like a quadratic within a quadratic. Now we have to do either factoring or a quadratic formula again. And in this case, since everyone who's listening to me now is pretty good at factoring, I'm going to factor. K times k plus 8 equals 0. So now we know that either this has to be 0 or this has to be 0 to multiply together and get 0, right? So in this case, the two possible solutions are k equals 0, which goes with that one, or k equals -8, which goes with that one, okay? All right, and so if k equals 0 or k equals -8, we know that the discriminant equals 0, so we're going to write that on our number line. Oops. We have -8 and 0, right? And at these 2 points, the discriminant equals 0, so I'm going to label them with zeros. Now I'm going to test a big negative value, like -100. If I put -100 into this one here, I'm going to get a negative number, like -100 times -92. Two big negative numbers multiplied times each other gives a positive number, right? So I know that all the values to the left of -8 are positive numbers, right? And then I'm going to test a value to the right, which is like positive 100. If I put positive 100 in this here, I'm going to get positive 100 times 108, and that will give me a big positive number too. And then I'm going to take a small negative number like -4 that's in between these two, and that will give me -4 times positive 4, which is a negative number, which is that. So the sign diagram has negative in between -8 and 0, has positive less than -8, and has positive greater than 0. Okay, so now I know what values of k give me certain values of delta. So this is delta negative, delta positive, delta 0, and delta 0. And I can write that out. I could write that like k is equal to 0 and -8 gives me a delta of 0, which means 2 repeated roots. If k is less than -8, or k is greater than 0, then delta is greater than 0, which means 2 real roots. And if k is between -8 and 0, then delta is less than 0, which means no real roots. Okay? So the complexity is introduced by the fact that this discriminant equation is now quadratic instead of just a linear equation, right? That was A. Now we're going to do C. So now this is a little bit even more complicated than the other one. We have to expand it first, right? So we expand k plus 2 quantity squared. We get k squared plus 4k plus 4 minus 16 equals 0. And so now we're going to combine 4 minus 16. We're going to get -12. Okay. And now to find the zeros of this, again, you could use quadratic formula. Okay. I'm going to just factor here because it's quicker for me. Okay, and then I think that works. No, actually it's the opposite. So it's I got the signs wrong here. It's k plus 6 and k minus 2. Okay, and then so the zeros here are going to be -6 and +2. K equals -6 or +2. I'm going to put that on the number line. -6, +2. And then I'm going to put in a big positive number like a positive 100. I'm going to get 106 times 98. That's a positive number. I'm going to put a number like 0, which is going to be 0 plus 6 is 6. 0 minus 2 is negative 2. Multiply those two together, I get negative 12, so that's a negative number. And of course, big negative number like negative 100 is going to give me negative 94 times 98. That's negative 102, right? Two negative numbers, multiply those together, I get a positive. So, and then of course at negative 6 and 2, I get zeros, right? And then it's going to be similar to this one here. So we're going to say, oh, when k equals negative 6, or 2, then 2 repeated roots, right? Delta equals 0. When k is greater than 2 or k is less than negative 6, then we have 2 real roots. And when k is between negative 6 and 2, then we have no real roots. Okay? Finally, we're going to do E. So first thing we need to do is expand. And so 3k minus 1 expanded is going to be 9k squared minus 6k plus 1. And then if we distribute the 4 here, it's going to be 4 times 2, which is negative 8k minus 4. And then set that equal to 0. We're going to start combining like terms here, and so we get 9k squared minus 14k minus 3 equals 0. And then we're going to break this up into, or we're going to factor this, and we're going to get, thought about it for a while, I don't think I can factor this. This is a great time to show you how you can do quadratic formula on the calculator without doing all that painful stuff. And unfortunately, you can't do this on half the IB exam. So that's why we spend so much time learning how to do it without the calculator. But first you go to Apps, then you go to Poly SMLT2, and then you hit the key here, and then you go to Poly Root Finder. Poly Root Finder finds the roots of huge equations, not just quadratic equations, but in this case we're going to do quadratic equations. So you say second order because quadratic equations are second order. Then we're going to put 3 coefficients here. We're going to put 9, negative 14, and negative 3. So 9, negative 14, and negative 3. And then we're going to do solve. Wow, that's terrible, isn't it? So one of the solutions is going to be k minus 1.74, 1.75. And the other one's going to be k is plus 0.191. Okay? And so if we did our number line, it's going to be negative 0.191, and here we're going to have 1.75. And then if we put a big positive number in here, we're going to have positive. If we put a big negative number in here, we're going to get 2 negatives times each other as positive. And then the middle part, if we put in 0, we're going to see we're going to get a negative times a positive, so we'll get a negative. So this is our number line, our sign diagram. And if we wanted to write out the results here, we'd say, oh, if k is equal to negative 0.191 or 1.75, then delta is equal to 0. So that means repeated root. And if k is less than negative 1.91 or k is greater than 1.75, then delta is greater than 0, which means 2 real roots. And if k is between negative 1.191 and 1.75, then we're going to have delta is less than 0, which means no real roots. And that's it.